Hello everyone. So today we're going to talk about relating limits to the horizontal asymptote line and the vertical asymptote line. And so during class practice, we saw that the function 1 over x as x approaches infinity went to 0. Okay, and the same thing as far as x approaches negative infinity, we saw that the function 1 over x approached 0. Okay, and so what I'm noting to you in general, alright, because we also saw a similar result as x approaches infinity for 1 over x squared, we saw that that fraction approached 0 as well. And so the idea here is, again, abusing notation. I'm going to say that within the limit, as x approaches infinity, we have that k over infinity goes to 0, and k over negative infinity goes to 0, where k is a real number. Okay, and so again, me saying this, I'm saying that within the limit, alright, as x approaches infinity, then I know that my constant divided by infinity approaches 0, and then same thing with constant over negative infinity. We know that this approaches 0. And so let's look at a concrete example so you can see what I'm talking about. So here, if I want to compute the limit as x approaches infinity of 3 minus 2 over x squared, I'm going to just focus here on the fact that really I'm trying to figure out what's the limit as x approaches infinity of 2 over x squared. Okay, and so the idea here is that what's in the denominator, we know that as x approaches infinity, x squared also approaches infinity, right? Because we have that x squared is this nice U shape, this upwards U shape, and so thinking about the end behavior, you would say as x approaches infinity that we know that the function x squared also approaches infinity. So I have in this case what's highlighted in yellow, a number divided by x squared, but in this case we know that within the limit I have a number divided by infinity. Alright, because here I'm saying to you, okay, well I know that the end behavior of x squared is infinity, and so within the limit I have that a number divided by infinity in air quotes. And so I'm telling you that this is an abuse of notation here. But what you want to note is that I'm not plugging in infinity when I'm trying to figure out the 2 over infinity. Okay, I'm not plugging in infinity for x and squaring it or anything like that. I'm looking at the end behavior of x squared, and I know that the end behavior there is going to be infinity. So now, just showing this out here, I can say that using the properties of limits, I have that this is the limit as x approaches infinity of 3 minus the limit as x approaches infinity of 2 over x squared. And so again, using the properties of limits, I know that this limit here is just going to be 3. Okay, because remember that the limit of a number is just that number. And so we just discussed here that the limit as x approaches infinity of 2 over x squared, we're in that, in air quotes, 2 over infinity case, and so within the limit we say that that approaches 0. So I have that this is minus 0. And so overall we say that this limit is 3 minus 0, which is 3. And so again, I'm just noting here that we have 2 over infinity, which is approaching 0, since as x approaches infinity, x squared approaches infinity. Okay, and so that's how we have this 2 over infinity, and so I'm saying within the limit, we know that that limit, within the limit, if we have 2 over infinity, I know that that's going to be approaching 0, and so in other words, the limit as x approaches infinity of 2 over x squared is just 0.